Hello everyone, and just gonna say welcome back to my YouTube channel and my math videos. I'm here to provide high quality mathematics instructional videos. Today we'll be back to Math 125. The topic will be the advanced technique of approximating integrals. So let's get started. Call them Calc 2 instead of calculus 2 because it's the same. The topic will be section 7.7 approximating integrals. Call them advanced approximation. So like we discussed in previously section way back in 5.1, we talked about like the midpoint, right endpoint, and the left endpoint. So far, and just we learned there are three techniques I've learned so far in the course. Number one is just gonna be like a left endpoint. And it always just underestimate for increasing function, but overestimate for decreasing function. Number two is we have it's the midpoint. And this one just usually the kind of the most accurate one if you want to do like approximation. But we have more accurate kind of integrated technique that I will teach you this in, in this video. Lastly, we have number three. We known as like a right endpoint. For right endpoint, it is usually overestimate for increasing function, but decreasing for but underestimate for decreasing function. And also like the basic technique. We want to learn like a more advanced. So today we are introducing two advanced technique. It's two advanced technique. We are having number four, which is going to be trapezoid rule. Number five, we have over number five, which will be this Simpsons rule, number five. And those are like the five most common, like approximate integral when you cannot integrate or the integral is too hard to compute. So what is the notation for trapezoid rule? So trapezoid is like the just like a trapezoid. So for the trapezoid rule is be just approximate, just like a trapezoid, like this. And how we write the notation, it will be perhaps the same notation as a function f of x over the interval a and b. I'm just to write like the notation rather than just write like the function here. So for trapezoid, the t and will be like the notation here. So for tn from a to b, it is gonna be the trapezoid rule of this integral it is equal to you're gonna be like 1/2 of delta x. Then it's gonna be f x x x o, then 2 fx1. And but to the last one, we still have 2 fxn minus 1 plus fn is like the end point. Fxn. Hope you can still see like my writing here. This is a trapezoid rule, so we can take 1, 2, 2, 2, 2, 2, 2 until last point. So this is like the trapezoid rule. For next one, Simpson rule is more. I think it's more of a complicated, but it's not. Well, for Simpson rules, the only rule like only can be even number subintervals. So it must be even. And how we write them is we have this S seem like the Simpson rule of the same integral. It's going to be 1 over 1/3 times delta x is going to be fx to fxo. I'm gonna make sure it is here, right? You can still see, right? Okay, I'll just adjust here. And then we have 4 fx1. We have plus 2 fx2. And then plus da. We have 4. It's gonna be like f of x and minus 1. And then we have it plus f x to the n. So it's like a last point. Simpson's rule is more of a like 1424242. You probably remember like, oh, Simpson. This correct. This is going up, down, up, down, down. That's more like his head. Now let's do some like. Now let's do some example. So the first example, and it's gonna be, we have a function f of x is equal to the natural log of x to the 10th minus 5x. So plus 5x minus 1. And you probably just don't want to do integration by part, right? We have interval, well, n which is from a equals to 1, b equals to 3. Perhaps we have this, and we wanted to approximate the area under the curve. Just use approximation. Under the curve, so I'm just assuming it is just above the x-axis. So this is just a more like back to section 5.1, which we are just approximating like a basic integrals. So perhaps so from 1 to 3 here, so we just to approximate this area. Perhaps you just assume, okay, here's the function, but not to scale. And you just want to write on the notation, and it's gonna be used like, here we take a curve here. So in this case, we want to do n equals to 4. This question I'm going to do n equals to 4. So how do you make it to approximation like into the 4? So 1, 2, 3 is a 2. And we want a 4 subinterval. So we need to I make a cut here. So we're going to be 3 over 2, 2, and then 5 over 2. And we just make this approximation. And this is the width, 1/2. And if you want to do trapezoid 4, so T4, how to do T4? We have some of like the delta x is gonna be 3 minus 1 over 4. It is 1/2. And you just want to compute. We don't need to integrate this whole thing. So if I want to write out the integral, and it's gonna be like, I bet you do not want to integrating this, right? And this is just too hard to integrate because like it's hard, and so we just do some like the like the approximation. So it's gonna be 1/2 times delta x gonna be 1/2 on and there's like gonna be this, and we just multiply them. F x0 is gonna be from 1 and then 1.5, 2 and 2.5. So it's n4 we take like from 1 to 2.5. So gonna be f1 and plus 2 f f1.5 and then plus 2 f2 and then plus 2 f.2.5 plus f2 and plus f3, including all the point here. I mean, just to because I don't want to, because x to the 10th of like non-integers it is hard. So I'm just gonna say gonna be 1/4. I'm gonna take out my calculator because like because 1.5 to the power of a 10 it is, yeah. So it's gonna be 1 gonna be 1 plus 6 is gonna be 5. So 2 gonna be 1.5 to the 10th plus 6.5. And we just gonna do some like the approximation. So I'm gonna leave it like a 2 decimal places. So it's gonna be a natural log of 16 point. So it's gonna be like a natural log of 5, not 5. So gonna be natural log of 64.17 plus 2 gonna be 2 times 10 to the 10. There's 100, 133. I'm just gonna do some gonna be 2.5 plus 11.5, 9.16 times 2 gonna be 18.32. After the 3 is gonna be natural log of 3 times 10 plus gonna be plus 14, be 10.99. The most part is computational, so it's gonna be natural log of 5. So sorry if I make the mistake. So natural log of 5 is going to be a 1.61. So going to be 1.61 plus going to be 2 natural log of a 64.17 is going to be a 8.32. Going to be plus 13.88. Also going to be 29. Going to be 30 points. And then we just compute those. We have 1 over 4 times 1.61 plus 8.32 plus 13.88 plus 30.31. 30.31. It's gonna be 13.53. Okay, and now we try to do Simpson's rule. So it's gonna be 1/3 of delta x. Here we have f1, so it's just gonna be like natural log of 5. And we have 4 is it's the same thing. We just plus 4 natural log of 2. So it's 4 natural log of and then gonna be 2 natural log of 1033, and we plus like 4 again. So we just do this answer gonna be the 4, we have this, and then plus 10.99. So gonna be 1 over 6 times natural log of 5 is a 1.61. So it's gonna be 60.64. After 2, this is gonna be 13.88. And then we plus this. It's gonna be 47 point. Gonna be 9. Yes. And we compute 1.61 plus 16.64 plus 13.88 plus 47.71. 13.31. So we definitely just assume like this, like it's something between this. Now we compute the actual value. The actual value was as compute 1 natural log of x to the 10th x to the 10th plus 5x and then minus 1 dx integral. Well, I'm just assume it is somewhere just under 13 or 14 or so, whatever it is. So I would say it is good. Now let's do another one, because I think it's just like easier concept. So I would not make a long video on this one. So last example going to be example number 2. So we just approximate. We have This integral is gonna be 8 and a 0. And you just don't know how to compute feel like e to the x to the squared dx with n equals to 5. In this case, if it's like an odd number, we just use like the trapezoid rule. So trapezoid rule is gonna be using the T5, and delta is gonna be 1.6. And we just say like the T5. It is from 1/2, 1/6, so gonna be 1/2 of 1.6 from 0, 1.6. So gonna be 0, 1.6, 3.2, then 4.8, 6.4, and 8. And we just gonna be f1, so gonna be f0 plus 2f of 1.6 plus 2f of 3.2, then plus da 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 da, then plus f8. I'm just gonna compute this. So it is gonna be gonna be 0.8. F0 is a 1. E to the 0 is 1. 1.6 is gonna be 2. E gonna be 2.56 plus 2. F gonna be 3.2 squared, gonna be 10.24. So gonna be 2, gonna be 10.24. And then plus that gonna be plus 8 can be e to the 64th. Now let's compute. So 2e 2.56 is gonna be 2587. So we just say combine this, gonna be 1 plus 51.74. We have this gonna be e to the 10.24. So it's gonna be 56001. Wow, this is big. And then we have 4.8, so it's gonna be 2304. It's gonna be e to the 2304. That's a huge number. It's a huge number. So for the tips, there's no rules on whatever rule can use, but if n is even, so you have like a 4 or 8 sub intervals, use Simpson rules. If you have any random number of an interval, use any rule you want. And then that is all for section 7.7. This is the easier one. And have a wonderful day.